Here we go. 3C12 part B. I'm so sorry that I don't get to give y'all a break. We got to push through because of state testing. So part B is to rewrite trigonometric expressions in equivalent forms with sine and cosine sum identities. So we're going to be learning more identities. I know, crazy. So we're going to learn some additional identities. Please don't come for me and please don't be mad at me. But here we go. Okay, so in this section, we're going to study two different categories of trig identities. We will use formulas to involve sum and difference to verify identities and double angle formulas. So here are our new identities. They're basically formulas because you're plugging in. You're going to be plugging them in. So yes, they're identities, but they're formulas because you're going to be given values and plugging them in. Does that make sense? Okay. So up first, we have sums. So the sums for sine and cosine, this is the rule. If you're adding two angles together and you're finding the sum of it, it expands to be sine of alpha, sine of the first angle times cosine of the second angle plus cosine of the first angle times sine of the first angle. Sorry, can't talk. Cosine of the first angle times sine of the second angle. Okay, that is all it is. It's just a pattern. Sometimes, well, for me, I just minimize it to be SC plus CS, and that just helps me remember what order I'm going in. Okay, again, how I memorize doesn't have to be how you memorize. So it's up to you. Okay, cosine, remember those X's are always liars. Okay, cosine represents X. So even though it looks like you're going to be adding them, when you actually are finding the sum, you are subtracting. So for cosine of alpha plus beta, I remember it as CC minus SS. The differences are the same, except opposite sides. So the difference between two angles, finding the sum of the difference between two angles, it's going to be sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. And then the difference between two angles of the cosine difference, you get what I'm saying. It's not coming out for whatever reason. It's going to be cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Okay. Then the next our next formula that we're going to be using is our double angle formula. So our double angle formula is sine 2u. Why is it switching to u? It doesn't matter. It could be u, it could be x, it could be theta, it could be beta, it could be whatever as long as it's a variable. So 2 sine u times cosine u. And that's it. Now, cosine is the one that gets a little funky, a little weird. It has 3 rules that it can follow. The reason why it has 3 rules is based off of the Pythagorean identity. Does that make sense? So all they did was to find the other 2 rules, they just substituted in what they equaled using the Pythagorean identity. And that's how it came down to this. So anyway, these are the 3 rules. This is the main one. And then this one was manipulated. These are the 2 that comes from that. Depending on the problem, you'll choose which one you use. How do you know which one you use is based on the information given to you. Okay. If all I'm given is the cosine, guess what I'm going to use? I'm only going to use the second one. If all I'm given is the sine, I'm only going to use the third one. Okay. So it just depends on the information given. Now, why is this useful? Well, this is useful because on your unit circle that we reviewed, do we have every single radian value listed? No, we do not. But for a good portion of them, we can use the radian values that we do have listed in order to evaluate expressions without a calculator. Okay, so for example, if I ask you for the sine of 5 pi over 12, well, the sine of 5 pi over 12, 5 pi over 12, is that on our unit circle? No, it is not. But what is on our unit circle are 2 angles that can be added together to make 5 pi over 12. Okay, those 2 angles that add together make 5 pi over 12 are pi over 6 and pi over 4. Okay, reason being is pi over 6 is 2 pi over 12. And pi over 4 is 3 pi over 12. And what does that make? 5 pi over 12. Okay, so we're going to use the sum of 2 angles for sine in order to evaluate. So we have sine of 5 pi over 12 equals the sine of pi over 6 plus pi over 4. That's what they equal. No, we're literally finding two angles that add up to equal that.
Wait, I guess the answer.
No, we haven't plugged into the formula yet.
Oh.
This is showing you why these two equal 5 pi over 12. Yes. Or you just put them in non-reduced form and see that they make the same. Yeah. If I need this to be 12, how does 6 become 12? If I need this to become 12, how does 4 become 12? Ta-da! You did it. All right. So now, remember I said think of these not as identities, but as formulas, okay? The reason why we think of them as not identity, but as formula is that we're going to label them. So this is our alpha, right? My alpha just is going to look like an A. Just go with it. And this is our beta. So we're going to plug them into the formula, okay? So sine, remember I told you in my brain, when I see sine, I'm going to think of this because that's how I remember it. So I'm going to expand this so that it looks like the real version of that. So it's the sine of the first angle. So the sine of pi over 6 times the cosine of the second angle times cosine of pi over 4 plus the cosine of the first angle, cosine of pi over 6 times the sine of the second angle times sine pi over 4. And then at this time, your handy dandy unit circle comes out. Okay, what is the sine of pi over 6? 1/2. What is the cosine of pi over 4? What is the cosine of pi over 6? What is the sine of pi over 4? Pi over 4, square root of 2 over 2.
Oh.
And all we did was use the unit circle. And now we're going to multiply. Numerator times numerator, square root of 2 over 4. Plus numerator times numerator, square root of 6 over 4. You cannot combine radicals unless they are the exact same. So this is where you stop. Could you technically be technical and factor out square root of 2? Yeah, but that's pointless. Do you see why I said to think of it as a formula instead of an identity? Because with formulas, we plug things in, right? Identities, we use them to like puzzle pieces and manipulate, right? Here, we plug things in. You just got to remember which one you're using. And you also have to be able to know which angles you're using. Yay, nay.
Like, say if we were taking a test or something
Mhm.
and we were doing over this, I can just like write the pi circle.
You're gonna
I
circle.
could just write it on the like use this.
That's why I encourage when you start on your non-calculator before on your scratch paper, I would just go ahead and draw my unit circle so that I can just reference it when I need it. And I don't have to come, already just brain dump. It's okay. All right. So again, cosine 7 pi over 12. So cos 7 pi over 12, is that on our unit circle? No. But are there two angles on the unit circle that can be added or subtracted for that? Answer is yes, there are. They would be pi over 4 and pi over 3. Okay. Reason being, double checking, pi over 4 becomes 3 pi over 12. Pi over 3 becomes 4 pi over 12. Does that make 7 pi over 12? Maybe, maybe not. Okay, what I would like for you to do is to try using the sum of cosine and expand it and solve it. So sum of cosine, remember for me, I remember things as CCE minus SS because X's are liars. So cosine is not going to be addition when I expand. It becomes subtraction. Okay. All right. So give it a shot. Yep. You're going.
So
All right. Let's talk about it. So once you expand to your addition and subtraction, your addition problem. Huh?
okay, that's how I said it.
Oh. So now you have your A and your alpha and your beta. You're going to plug them in. So you have the cosine of your alpha, which is pi over 4, times the cosine of your beta, which is pi over 3, minus, remember, x's are liars, so cosine is the opposite of what you think. And then you have your sine of pi over 4 times the sine. Oh my gosh. Excuse this video outburst. Okay. Oh, sine of pi over 3. I will fix my pen at some point.
This will be equal sign pi. Yes. Wait.
Which one?
That's minus. Wait.
Minus sine pi over 4 minus it, then times sine pi over 3. Okay. And then this is where you go to your unit circle. So you go to your unit circle, or you think about your unit circle, and you're going to ask yourself, so what is cosine of pi over 4? And you're going to tell yourself, square root of 2 over 2. And then you're going to ask yourself, so what is the cosine of pi over 3? And you're going to say 1/2. Good job. Minus, so sine of pi over 4 is square root of 2 over 2. Gotta love those quarters, right? And then sine of pi over 3, therefore, has to be square root of 3 over 2. When you multiply numerator times numerator, denominator times denominator, so we get square root of 2 over 4 minus square root of 6 over 4. Notice the difference is simply what? It's a minus. That's it.
That's 6 squared.
How do we get it? 2 times 3. Square root of 2 times square root of 3 is the square root of 6. It's a formula. Formulas are easy. I'm trying to tell you all this. Formulas are easier. That's why I said don't think of them as identities, but think of them as formulas.
Yeah, where you just plug them in.
Okay.
Like it looks like the last.
Now, when you're doing all your homework, you're not going to have me to tell you what two angles you're picking. So you're going to have to be comfortable with picking them yourself, finding the common denominator, seeing what adds to make what. Okay. Looks like we only have 3 minutes left in class. So this is gonna have to be where we stop on part B. We don't have time to do that. So I'm gonna have to finish making the videos and you're gonna have to watch them. Because we have to be starting 13 on Monday. Okay, we have to start 13 on Monday.
Anyway.